Dear children, welcome to our channel GG Reddy Math Academy. Smart Learning Trigonometry. Remember Socato. S-O-H-C-A-H-T-O-A. Socato. Sin theta opposite by hypotenuse. Cos theta adjacent by hypotenuse. Tan theta opposite by adjacent. For theta opposite sides, for theta this is adjacent side and this is hypotenuse. We learn angles also here. Socato, S-O-H, sin opposite by hypotenuse, cos cosine, cosine adjacent by hypotenuse, tan tangent, tangent opposite by adjacent. Right triangle representation. This is right triangle. For theta opposite side is this one. For theta this is adjacent side and this is hypotenuse in the right angled triangle. Formula: sin theta equal to opposite side to theta by hypotenuse. SOH, sin opposite by hypotenuse. Formula: cos theta equal to adjacent side to theta by hypotenuse. Cos equal to adjacent by hypotenuse. Formula: tan theta equal to opposite side to theta by adjacent side to theta. TOA, toe. Tan equal to opposite by adjacent. Summary: identify angle theta. Label opposite, adjacent, hypotenuse. Apply correct formula. Reciprocal ratios. Reciprocal ratios are inverse of basic trigonometric ratios. Sine and cosecant, sine and cosecant are reciprocals. Sin theta equal to opposite by hypotenuse, cosecant theta equal to hypotenuse by opposite. Multiplication: sin theta into cosecant theta is equal to opposite by hypotenuse into hypotenuse by opposite. After cancellation we are getting 1. So sin theta into cosecant theta equal to 1. Sin theta equal to 1 by cosecant theta. Cosecant theta equal to 1 by sin theta. All these are formulas. Cosine and secant are reciprocals. Cos theta equal to adjacent by hypotenuse. Secant theta equal to hypotenuse by adjacent. Multiplication: cos theta into secant theta equal to 1. Cos theta equal to 1 by secant theta. Secant theta equal to 1 by cos theta. Tangent and cotangent are reciprocal ratios. Tan theta equal to opposite by adjacent. Cot theta equal to adjacent by opposite. Multiplication: tan theta into cot theta equal to 1. Tan theta equal to 1 by cot theta. Cot theta equal to 1 by tan theta. Summary table: ratio, reciprocal, product. Sin theta reciprocal cosecant theta. Sin theta into cosecant theta is 1. Cos theta reciprocal secant theta. Cos theta into secant theta equal to 1. Tan theta reciprocal cot theta. Tan theta into cot theta equal to 1. Right triangle, right angled triangle. This is adjacent side to theta. This is opposite side to theta. This is hypotenuse. Basic ratios: sin theta opposite by hypotenuse, cos theta adjacent by hypotenuse, tan theta opposite by adjacent. Derivation of tan theta: tan theta equal to opposite by adjacent, sin theta by cos theta equal to opposite by hypotenuse by adjacent by hypotenuse. This is equal to opposite by adjacent. Therefore tan theta equal to sin theta by cos theta. Derivation of cot theta equal to adjacent by opposite, cos theta by sin theta is equal to adjacent by hypotenuse by opposite by hypotenuse. This is equal to adjacent by opposite. Therefore, cot theta equal to cos theta by sin theta. Our goal, we will prove sin 0 degrees, sin 30 degrees, sin 45 degrees, sin 60 degrees, sin 90 degrees using geometry plus triangles. Proof of sin 0 degrees. At 0 degrees, opposite side equal to 0. Sin 0 degrees is equal to opposite by hypotenuse. This is equal to 0 by hypotenuse is equal to 0. Proof of sin 90 degrees. Concept, at 90 degrees, opposite side equal to hypotenuse. Sin 90 degrees is equal to opposite by hypotenuse. This is equal to hypotenuse by hypotenuse. This is equal to 1. Therefore, sin 90 equal to 1. Proof of sin 30 degrees is equal to half. Take an equilateral triangle of side 2 units. This is side 2 units. This is also side 2 units. And this is also side 2 units. Here we are finding, we wanted to prove sin 30 degrees is equal to half. So taken here, this is angle bisector, that is 30 degrees. Here this angle bisector is here median. So this angle bisector or median passing through midpoint of other sides, so it will divide. This is 1 unit and this is 1 unit. So here ACB, ADC, you can take ADC is a right angled triangle. Also BDC is right angled triangle. This I am taking as height, altitude. So this is angle bisector, this is altitude, and this is median. Here 60 degrees, here also 60 degrees, here 30 degrees and 30 degrees. This is equilateral triangle. Important observation, in an equilateral triangle, median is equal to altitude equal to angle bisector. So the altitude divides 2 units is equal to 1 unit plus 1 unit, and 60 degrees is equal to 30 degrees plus 30 degrees. Consider the right triangle formed. Sin 30 degrees is equal to opposite side by hypotenuse. Opposite side for 30 degrees in the triangle, you can see opposite side is 1 unit, hypotenuse is 2 units. Therefore, sin 30 degrees is equal to half. Proof of sin 60 degrees is equal to root 3 by 2. Using the same equilateral triangle, find the height using Pythagoras theorem. In right triangle, triangle ACD, h square equal to 2 square minus 1 square, h square equal to 4 minus 1, h square equal to 3, h equal to root 3. Now in right triangle ACD, sin 60 degrees is equal to opposite side by hypotenuse. This is equal to root 3 by 2. Therefore, sin 60 degrees is equal to root 3 by 2. Proof of sin 45 degrees is equal to 1 by root 2. Using a square, take a square of side 1 unit and draw its diagonal. This is 1 unit and this side is 1 unit, this side is 1 unit, this side is 1 unit. Diagonal, I am getting root over 1 square plus 1 square, that is root 2. Diagonal, I am getting root 2. Here this is 45 degrees, this is also 45 degrees, all this is 90 degrees. Here 90 degrees, here 45, and then here also 45. Here 90 degrees. Okay, so I need to find sin 45, right? Sin 45. This is the triangle I am going to use. ABC triangle I use. Here 90 degrees. So sin 45 is equal to opposite by hypotenuse. So 1 by root 2 I will get. Find the diagonal using Pythagoras theorem. In right triangle ABC, AC square equal to 1 square plus 1 square, AC square equal to 2, AC equal to root 2. Now, in right triangle ABC, sine 45 degrees is equal to opposite side by hypotenuse is equal to 1 by root 2. Therefore, sine 45 degrees equal to 1 by root 2. Standard values of sine theta. For theta equal to 0 degrees, sine 0 equal to 0. For theta equal to 30 degrees, sine 30 degrees equal to 1 by 2. For theta equal to 45 degrees, sine 45 equal to 1 by root 2. For theta equal to 60 degrees, sine 60 degrees equal to root 3 by 2. For theta equal to 60 degrees, sine 60 degrees equal to root 3 by 2. For theta equal to 90 degrees, sine 90 degrees equal to 1. Memory trick. Sin theta equal to root over 0 by 4, comma root over 1 by 4, comma root over 2 by 4, comma root over 3 by 4, comma root over 4 by 4. For this is 0, 1, 2, 3, 4 pattern. Okay. So for theta equal to 0 degrees, root over 0 by 4. For theta equal to 30 degrees, root over 1 by 4. For theta equal to 45 degrees, root over 2 by 4. For theta equal to 60 degrees, root over 3 by 4. For theta equal to 90 degrees, root over 4 by 4. Okay. Our goal, we will prove cos theta and tan theta for 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Proof of cos 0 degrees. At 0 degrees, cos 0 degrees is equal to adjacent by hypotenuse. This is equal to adjacent becomes hypotenuse. So hypotenuse by hypotenuse is equal to 1. So at 0 degrees, adjacent becomes hypotenuse. So hypotenuse by hypotenuse gives 1. Proof of cos 90 degrees equal to 0. Goal, we want to prove cos 90 degrees equal to 0. Recall cos theta equal to adjacent side by hypotenuse. Step 1. Start with a right triangle. This is right triangle, adjacent side to theta. This is opposite side to theta. This is hypotenuse. Cos theta equal to adjacent side by hypotenuse. Step 2. Increase the angle. As the angle theta increases, the adjacent side becomes smaller. The triangle becomes more vertical. The opposite side increases. Here see, if it is 30 degrees, this is the triangle. If this theta increases, if 30 degrees increases, if it is 70 degrees, the triangle becomes like this. If it is 90 degrees, the adjacent side becomes 0, right? When angle becomes 90 degrees, opposite sides, hypotenuse, adjacent side becomes 0. This is important. Step 4, apply the formula. Cos theta equal to adjacent side by hypotenuse. At theta equal to 90 degrees, cos 90 equal to 0 by hypotenuse. Cos 90 degrees equal to 0. Therefore, cos 90 degrees equal to 0. Proof of cos 30 degrees equal to root 3 by 2. Using an equilateral triangle. Take an equilateral triangle of side 2 units and draw the altitude. This is equilateral triangle, 2 units, 1 plus 1. This is also 2 units. This is median, this is altitude, and this is angle bisector. So this 60 degrees is divided into 30 degrees. As this is median, this 2 units is divided into 1 unit and 1 unit. This height becomes, this is right angle triangle ADC. Triangle ADC is right angle triangle, so we can use, by using this 2 and 1, I can find altitude, I can find height by using Pythagoras theorem. So observation, in the right triangle formed, adjacent side is equal to root 3. So I got this by using Pythagoras theorem. Hypotenuse equal to 2, cos 30 degrees equal to adjacent side by hypotenuse. This is equal to root 3 by 2. Therefore, cos 30 degrees equal to root 3 by 2. Proof of cos 60 degrees equal to half. from the same equilateral triangle of side 2 units, we are getting this. So I can find cos 60 degrees equal to adjacent by hypotenuse. So 1 by 2. Observation: in the right triangle formed, adjacent side equal to 1, hypotenuse equal to 2. Cos 60 degrees equal to adjacent side by hypotenuse. This is equal to 1 by 2. Therefore, cos 60 degrees equal to 1 by 2. Cos 45 degrees equal to 1 by root 2. Take a square of a side 1 unit and draw its diagonal. This is a square, each side is 1 unit. Here this is 45 degrees and the diagonal I got root 2 and here 90 degrees. So cos 45 degrees is equal to adjacent by hypotenuse, that is 1 by root 2. I am getting 1 by root 2. Find the diagonal using Pythagoras theorem. In right triangle ABC, AC square equal to 1 square plus 1 square, AC square equal to 2, AC equal to root 2. Apply cosine formula. Cos 45 degrees equal to adjacent side by hypotenuse. This is equal to 1 by root 2. Therefore, cos 45 degrees equal to 1 by root 2. Proof of tan 0 degrees. Tan 0 degrees equal to opposite by adjacent. This equal to 0 by adjacent equal to 0. Proof of tan 90 degrees. Tan 90 degrees equal to opposite by adjacent. This equal to opposite by 0. This equal to infinity. Not defined. Infinity means here undefined, not defined. Tan 90 degrees is undefined. That is tan 90 degrees is equal to infinite. That is not defined. Proof of tan 30 degrees equal to 1 by root 3. Take an equilateral triangle of side 2 units and draw the altitude. This is 30 degrees and this is also 30 degrees. This is 60 degrees. This is 60 degrees. They are asking to find tan 30 degrees. So tan 30 degrees, for 30 degrees opposite side is 1. For 30 degrees opposite side is 1. For 30 degrees adjacent side is root 3. So tan 30 degrees I will get 1 by root 3. Observation: for angle 30 degrees, opposite side is 1, adjacent side is root 3. Tan 30 degrees is equal to opposite side by adjacent side is equal to 1 by root 3. Therefore, tan 30 degrees is equal to 1 by root 3. Proof of tan 60 degrees equal to root 3. From the same equilateral triangle, of side 2 units, this is 60 degrees. So for 60 degrees opposite side is root 3 and adjacent side is 1. So root 3 by 1. I will get root 3 by 1. Tan 60 degrees is equal to root 3 by 1. That is root 3. Tan 60 degrees equal to root 3. Observation: for angle 60 degrees, opposite side is root 3, adjacent side is 1. Tan 60 degrees equal to opposite side by adjacent side. This is equal to root 3 by 1. This is equal to root 3. Therefore, tan 60 degrees equal to root 3. Proof of tan 45 degrees equal to 1. Take a square of side 1 unit and draw its diagonal. Observation: for angle 45 degrees, opposite side is 1, adjacent side is 1. Tan 45 degrees equal to opposite side by adjacent side. This is 1 by 1 equal to 1. Therefore, tan 45 degrees equal to 1. Standard trigonometric values for angle 0 degrees, sin theta, cos theta, tan theta. We are finding here. For angle 30 degrees, sin 30, cos 30, tan 30. Given values here. For theta equal to 45 degrees, sin 45, cos 45, tan 45. For theta equal to 60 degrees, sin 60 degrees value, cos 60 degrees value, tan 60 degrees value. For theta equal to 90 degrees, sin 90 degrees value, cos 90 degrees value, tan 90 degrees value, undefined, not defined. Reciprocal trigonometric ratios: theta, cosecant theta, secant theta, cot theta. For reciprocal cosecant theta, secant theta, cot theta, reciprocal ratios of sin theta, cos theta, tan theta respectively. So for theta equal to 0 degrees, cosecant 0 is undefined, secant 0 degrees is 1, cot 0 degrees is infinite, undefined. For theta equal to 30 degrees, cosecant 30 is 2, secant 30 is 2 by root 3, cot 30 is root 3. For theta equal to 45 degrees, cosecant 45 degrees is root 2, secant 45 is root 2, cot 45 is 1. For theta equal to 60 degrees, cosecant 60 degrees equal to 2 by root 3, secant 60 degrees equal to 2, cot 60 degrees equal to 1 by root 3. For theta equal to 90 degrees, cosecant 90 degrees equal to 1, secant 90 degrees is undefined, cot 90 degrees is 0. Important relation, tan theta equal to sin theta by cos theta. Use this to verify all tan values. Memory trick, cos pattern, reverse of sign. So what is memory trick? Cos pattern, reverse of sign. Sign values 0, 1 by 2, 1 by root 2, root 3 by 2, 1. For 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees respectively. So for cos reverse pattern, 1 root 3 by 2, 1 by root 2, 1 by 2, 0. Reverse pattern. Cos pattern is reverse of sign. That is memory trick. Cos pattern is reverse of sign. Master trigonometry, learn, practice, score full marks. Thank you children. All the best for your exams. Write all these formulas and proofs in your notebooks. Practice daily for perfect results. You can score full marks. God bless you. Don't forget to subscribe. Don't forget to like the video. Don't forget to comment. Thank you children. That is the help you are doing to me. Thank you.